Welcome, ladies and gentlemen, to Unit 6 of ACT Prep, Perimeter, Area, Volumes, and Ratios. Before we get into the note, I want to make reference to the small phrase that is written at the top of every single page of this packet. Know your formulas. We talked a little about this in class. We're going to be doing some formula work. There's 10 formulas that show up most often in problems like this, and those need to get into memorization with perimeter, area, and volume. And it's important that you be working on those. We talked about a bit in class. They're all here in this packet. And you need to work on those because we're going to have 2 shots for you to do it without any matching, just what you can remember off the top of your head, and then a shot with matching as well. And you'll get the best score out of the 3, so please start to work on those as we get into the notes here. Okay, now down to business. Perimeter, area, and volume, and ratios here at the end. Okay, perimeter you've been working with forever. It's just the distance around the exterior of a shape. That goes for any shape except a circle, in which then we call it circumference. Okay, circumference we can use one of 2 options. If we have the diameter, we just multiply it by pi. If we have the radius, we just multiply it by pi, but then by 2, because then 2 radii would equal a diameter anyway. So our first question, a rectangular lot measures 150 by 200 feet. Anytime they reference something that I can draw, I like to draw a picture. And it's completely fenced. What's the length in feet of the fence? The length. Okay, we're not looking for area. We also know that being a rectangle, opposite sides have the same length. So if I add those 4 sides up, I end up with the correct answer. I have to be careful because you might just think 150 and 200, add them up, it's 350. There's the answer. But remember, you have to add all the sides. Down here in the figure shown below, each pair of intersecting line segments meets at a right angle and all the lengths are given in inches. What's the perimeter? Now most of us would look at that and we'd start saying, okay, I don't know this side, I don't know this side, I don't know this side, I don't know this little side. Start trying to figure that out with all the information there. And sometimes that might be easy enough to do, but other times that can be a bit tricky. So here's a suggestion I have, and this is going to seem kind of strange. So before you ask me what the heck I'm doing, just kind of watch. I'm going to go around the outer edge of my shape and I'm going to make it a rectangle. You're like, can you just make it any shape you want? No, but here's what I wish I could do with moving some things around. If I were to take this side, stretch it out, okay, take this 6, stretch it up, stretch it up, stretch it out, stretch it up, it would make a rectangle. All of the sides would not change in size at all. You would just look at a different way that it shows up. So, what good does that do me? Well, we just talked about up here, a rectangle has opposite sides that are equal. So if this side of my rectangle here is 26, the opposite side also has to be 26. You're like, okay, what about this side though? Okay, if I take the 4 and the 6 and the 4 and I were to line them all up on the left side of this rectangle, it would equal the same. So 4 plus 6 plus 4 is 14, and then I'm just going to add up all the sides. 26 and 14 is 40, and another 40 is 80 inches. Okay, makes life a whole lot easier. Again, you have options here. I just want to show you one of them as we work through. If you move up a little. Next one, if the radius of a circle is 3 centimeters, what is its circumference? Leave your answer in terms of pi. Okay, so circumference, in this case, since it's radius, would be 2 pi r, which is 2 times pi times 3. And it said to leave it in terms of pi. So my circumference is 6 pi. You might have answers that show up like that. Next formula to work with, the area of a parallelogram. Okay, 2-dimensional, base and height. Parallelogram with height with dimensions in inches is shown in the diagram below. What's the area of the parallelogram in square inches? Okay, my base, since it's the parallelogram as a whole, goes all the way across here. So my base is going to equal 9. My height is always something that's going to be perpendicular to the base. Well, what's perpendicular mean? It means it makes a right angle. You can tell by the little square there. So my height is going to be 4, and 9 times 4 is 36. So you start to see how understanding what the different parts mean helps you to really make it much easier when you're working with the formula. Again, Shannon here, as we move to the next page, is planning to make a tile rectangular kitchen countertop. Another opportunity to draw a picture. 24 inches wide and 64 inches long. She needs one tile for each 4x4 region. So the whole countertop, if I work that out, is going to be 1,536 square inches. The area of one tile is 16 square inches. So how can I figure out how many of these fit in there? That's right. We're just going to divide them in. Now, hopefully it goes in evenly, and it does. But if it didn't, we'd have to round to our nearest tile. Okay. Area of a circle, pi times radius squared. The diameter of a circle is 16. So if the diameter is 16, what's the radius? Half of that, right. So the area then is pi times radius squared, which would be 64 pi. And it says leave it in terms of pi, so that's what we're going to do. Okay, example 7. A 6 by 8 inch rectangle is inscribed in a circle as shown below. Just means it's stuck inside of it. What's the area of the circle in square inches? Make a triangle to find the radius. Okay. So if I make a triangle, we know those are right angles. What could I do to figure out? In this case, it'd be the diameter, but that'll lead me to the radius. Oh yeah, the Pythagorean Theorem shows up again. A squared plus b squared equals c squared. So we'll square those. Add them up, and we find out our x is going to be 10, because we have to take the square root, of course, to get the x value. But again, I'm not done. I'm trying to find the area of the circle. So if it's 10 all the way across, makes my radius equal 5 inches. And then I can do area equals pi r squared. And it looks like we're remaining in terms of pi. So there can be multiple steps. It might be just more than knowing what the area of a circle is to be able to find the answer. But knowing the other parts helps you with this and kind of gives you an idea of what's going on. Bottom of the page here, our next formula, area of a triangle. Same formula, just a couple different ways of looking at it. Vertices of a right triangle are located at coordinates. Again, they're giving me an opportunity to draw a picture. So I am going to do that. 0, 0, 4, 0, 4, 5. Connect the dots here. What's the area? So I need the base and the height. So I go, okay, 1, 2, 3, 4, 5, 1, 2, 3, 4. I have base and height. I don't need to find this. Some of you may say, I'll do the Pythagorean Theorem. No need, because I got base and height. Base times height divided by 2 gives me 10. And I'm set. So keep it simple when you can. And pictures are a great tool for doing this. Okay, as we flip over the page, we see the area of a triangle is 45 square inches. If the height is 5, what's the length of the base? Area is base times height divided by 2. We plug in what we know. We know the area. We know the height. We don't know the base. A little algebra to do. Don't like fractions. Want to get rid of that. Divide to get my b by itself. 18. Some of you may say, well, could I just start plugging these answers into this? So I could maybe, instead of doing the algebra part, I could take this 45 equals 5b over 2 and be like, okay, so 5 times 9 over 2, no, that doesn't work. 5 times 18 is 90 divided by 2. Guess and check is absolutely a strategy that works. So if you can get it to that base formula and then do guess and check instead of doing the algebra, I'm good with that. Okay? Whatever it takes for you to get to the right answer. Trapezoid, a little more interesting. I like looking at my trapezoid this way. I always like things being in one fraction instead of all this fraction times this times this. It just makes it easier, but it's the same thing. What's the area in square inches of the trapezoid below? Well, I got my base. I got my base. Uh-oh, I need height. And again, height's always something that's perpendicular. So here's where this one gets a little trickier. I know this piece is 6 because these are the same. If this whole part's 12, it means these two have the same piece that's left. So 3 plus 6 plus 3 would be 12, so that's how I figure out what these 3's are. I need to know what this is. You'll never guess what we're going to use. Yeah, Pythagorean Theorem again. But this time we have the hypotenuse and a leg. So hypotenuse squared minus leg squared equals x squared. And if some of you want to do 3 squared plus x squared equals 5 squared, it's going to get to the same answer. So nothing to fret about. Square root that guy. I get my 4. And you're like, phew. But we're not done. That just got us that. So now we got to plug it in. So the area is going to be base plus base times the height we just found divided by 2. So 18 times 4 is 72, divided by 2 is 36. And we're good to go. Now we're going to start throwing a few twists in here on you. The area of the trapezoid below is 20 square inches. The altitude, which is a fancy word for height, is 2 inches, and the length of one of the bases is 3 inches. What's the length and b of the other base? Okay, we're going to take the formula. Area equals, we know one of the bases is 3. I do not know the other one. I know the height is 2. Now, those of you that are always looking for a shortcut, here's your chance. Most of the time we'd say, well, we're going to multiply both sides by 2. But notice these 2's are right here. Not connected with a plus or minus or anything, so they can just cancel out. Let's keep life simple. Minus the 3. And we're good. And it went quickly. We like quick, but we like simple even more. So just something to keep in mind. Cutouts, you've seen them. Maybe not a formula before. Just take the big shape minus the little one. Okay, figure below shows 2 tangent circles, which means they share a point, nothing else, such that the 10 centimeter diameter of the smaller circle is equal to the radius of the larger. Okay, what's the area in square centimeters of the shaded region? We know the area of a circle is pi r squared. So for the big one, the radius is going to be 10, because that's my big circle. So in the big circle, we've got a 10 centimeter radius. So it goes from here to here, all the way across. So pi times 10 squared. Then for the little circle, we only want half of it. So we get a radius of 5. So pi r squared. 100 pi minus 25 pi. And then comes the big moment of truth, because we know 100 minus 25 is 75. But the question is, do the pi's go away? And whenever you ponder this, here's what I want you to think. If it were 100x minus 25x, what would you say? Well, you wouldn't get rid of the x's. You're like, it's x's minus x's. Same here. You've got to keep your pi. Okay, so far so good. This is a long section. All right, we're almost there. Don't get tired on me yet. Go take a break, get a snack, do what you have to, and kind of sit back here. Next, we're up to volumes. Volume of a box. There's 3 dimensions, length and width and height, to any volume that you're doing. So for example, in 13, what's the volume of a box in cubic feet in length? With length 8 feet, width 6 inches, and height 4 feet. Be careful. What's the typical person going to do here? They're going to say, well, I'm just going to multiply these together. 8 times 6 times 4 is 192. And they're going to go on. And they're going to be wrong. You're like, what? We're doing it in cubic feet. Ooh, we threw a measurement in inches in here. We don't want to do it that way. So let's try again. 8 feet. How many inches are there in a foot? Well, there's 12. So how much of a foot is 6 inches? Half, or 0.5, times 4. And that's what we're on the lookout for. So read carefully. If they change measurements, you have to make a conversion on that. Okay, after a snowstorm, City workers remove 10,000 cubic yards of snow from the downtown area. They spread it over the football field. How many yards deep would it be? Okay, so we got yards and yards. We don't have to worry about that at least. So now we're like, okay, so volume is length. Now be careful, my length is the whole field. 120 times width, 53.5, times height. We don't know what that is right now, but we know. You're like, Harty, why do I have two variables? Oh, wait, the volume is 10,000. Okay, so sometimes it pays to be able to have that stuff ready and raring to go. So we've got 10,000, our volume, equals 6420 once we multiply that together. And if we do 10,000 divided by 6420, we get 1.557, or about 1.56, and since we're just approximating, it's between 1 and 2. Okay? So again, just take the information and plug it in, but you have to know the formula to get there. Speaking of more volumes, we have the volume of a cylinder. Just got a little tipsy on you there for a minute. There we go. Pi r squared h, or the area of the base, times the height, in case it's not a circle. So you have the cylindrical milk tank. And they talk about the interior radius of the end is 4 feet. But then they talk about the length of the tank, and we don't see that. So this is where I like to draw something so it can be a little more visual for me. So the volume would be pi r squared. And h, even though it's a length here, we can count it that way. So I get here and I'm like, okay, 400 pi, and I'm ready to go about my business, and all of a sudden I'm like, ooh, those answers aren't matching up. If you have a pi button here, you can use it. If not, you can use 3.14. It's not that big of a deal because, again, we're just trying to approximate. So if you go ahead and type in the 400 times pi, or 3.14, you're going to get something around 1256, and it says closest, not exact. 1300 is the closest, so we go on to our last problem here. Okay, cones or pyramid. If it's a cone, you're going to use the pi r squared because it's a circular base. If it's something else like a square, a triangle, something like that, you'll use a third area of the base. So here we have a waffle cone. Radius of 3, height of 5. What's the volume? Okay, that's not hard. Pi r squared h, and I'm just going to divide by 3 instead of doing times 1/3. 3 squared is 9, times 5 is 45, divided by 3 is 15 pi inches. That'd be fun. Going to Culver's. Hi, I would like a waffle cone that is 15 pi cubic inches, please. They'll look at you like you're crazy, but it would be kind of funny. Whew, home stretch. We've made it to the last page. All right, last page. Problems get a little more interesting here. King Tut's car lot wants to make a replica pyramid with a square base. I am not good at drawing pyramids. I'll even show you here. Okay, so here's my base, and we're going up here and up here, and yeah, that's about as good as it gets for me. So the owner wants to make sure the volume of the pyramid is 6,000 cubic feet, and that the height's 45 feet tall. Now for our volume this time, we're going to do the area of the base, because it's not a circle, times the height, divided by 3. So, square base. Well, we know a square, all the sides are the same. So we know the volume is going to be 6,000 cubic feet. We don't know the area of the base yet, but here's one thing I do know. They're going to be the same on each side, so x times x is x squared times the height, 45, and we have to divide that by 3. So before we look at this as a whole, 45 divided by 3 would be 15x squared equals 6,000. We'll go ahead and divide by 15, which means x squared would be 400. And what do we square to get 400? Well, that would be 20. and that's one of my sides of the base. So again, it wasn't just about finding the volume. Sometimes they'll give you that. We found a different piece. So we've got to be flexible a little bit. Down the home stretch, volume of a sphere, 4/3 pi r cubed. So all they're going to tell us here, they give us the formula. They're nice every once in a while. Most of the time they won't be in these tests. If the radius of a spherical rubber ball is 1 1/4 inches. Now most of us are going to a calculator with this. So 4 pi, how do I turn 1 1/4 into a decimal? Right, 1.25. 1.25 cubed over 3. And again, if you're going to go calculating, get that part in first. Get your answer. So don't get cute here with trying to make sure. And you're going real fast, and then all of a sudden you're like, oh, oops, I shouldn't have done that. So when you multiply through, what do you get? Hopefully something around 8.18. Okay, and that would be your solution for that one. And the last one, this may be absolutely new to some of you. Okay, excuse me as I kind of get things back into shape here. Ratio of sides to a perimeter. You're looking at how big it is all the way around something, or how much area or volume there is compared to the original. And we're going to add a couple of little things here, because I want you to look at it as how you're doing it when you're doing it mathematically, not just the volume of a side to its area is a to a squared. But when we go to do this, okay, this also would be radii and circumference, just in case we have a circle. Okay, it would go with this one. So the radii of two circles is 49. What's the ratio of their circumferences? Well, it's going to be the same, but let me show you why. When you're finding this, circumference is 2 pi r. Okay? So if I split this off, one with a radius of 4, one with a radius of 9. So I do 2 times pi times 4. And again, you wouldn't have to show me all this work. I just want you to see where it's coming from. So 8 pi to 18 pi. Well, if I go to reduce it, what goes in 8 and 18? 2, 4 to 9. And that's where it's coming from. That's how it works with all of these. So for instance, even though you don't have the center, we'll call it like example 19a. Let's say we wanted to find the ratio of areas for these. So here, what I would do is I would look and I'd go, okay, I've got the radii is 4 to 9. So I do 4 to 9, but since I'm looking for areas, I square each of them. And I've got the answer. Okay? If it was volumes, I'd cube both of those and I'd have the answer. So the only thing you have to pay attention to is once you get the initial ratio, if it's perimeter or circumference, I leave it alone. It's the same thing. If it's areas, I square both numbers. If it's volumes, I cube both numbers. And I'm good with my ratio. So last one. A large cube has edges that are twice as long as that of a small cube. The volume of the large cube is how many times the volume of the small cube. That's a lot of stuff to keep track of here. The only thing I'm paying attention to here is a large cube has edges that are twice as long as a small. Okay, so let's say the small is, I don't know, 2 and the large is 4. And you could do 3 and 6, 1 and 2, 5 and 10, 1.5 and 3 if you're feeling kind of tricky. So let's look at it this way. Volume is length times width times height. 2 times 2 times 2, or 2 cubed, is 8. 4 times 4 times 4, or 4 cubed, is 64. How many times bigger is 64 than 8? 8. Now, is that just a fluke, Harty? Does that really happen every time? Well, let's check. Let's say S is 5 and L is 10. 5 cubed is 125. 10 cubed is 1,000. What's 1,000 divided by 125? 8. So it works every time. Thanks for making it far. This is by far the longest set of notes we're going to have. So if you've survived it, great. If you need to give yourself a little replay later, do so. But any other questions, we'll see you in class.